I did already. I'm recording.
Thanks, Jose. Yeah, so meeting is recorded. You can always ask questions via chat. Material, including slides and recording, will be available afterwards. So now moving towards the outline of the presentation, we have structured the presentation with these points. So starting with introduction and then giving a brief overview of the 5G Smart, and then I will explain you at very high level how 5G interworks with industrial applications. And then I will hand over to Jose, my colleague, who will provide insights to this network slicing tool that we have developed within 5G Smart. And this will also include a live demo. So without wasting any time, let's get started. So what we see in smart manufacturing domain today, this industrial transformation from 3.0 to 4.0. And there are two major trends that are driving the development of smart manufacturing. The first one is the more flexible production to increase the customization needs. And the second one is more autonomous operation to increase the productivity and improve the production quality. So in future, we will have industrial shop floor with machines equipped with wide range of connected sensors, with generating huge amount of data and which will be collected in real time and analyzed in real time as we don't see today. And connectivity will play an important role in this digital transformation of the smart manufacturing sector. And this should be supported with integrated wired and wireless communication infrastructure. And in that perspective, we see 5G from a wireless infrastructure point of view and TSN from a wired infrastructure point of view as a potential technology to enable reliable and secure transport of data in a timely fashion among the sensors and actuators. So in this direction, 5G Smart, full form of 5G for Smart Manufacturing, is working on demonstrating, evaluating, and validating 5G capabilities in these three industrial trials. As you can see on the slide, we have 5G system in Gista, in Aachen in Germany, in Reutlingen in Germany, at Bosch. Along with the demonstrating these capabilities of 5G system in a real trial, we are also looking into how 5G system integrates in whole manufacturing ecosystem. And also we are trying to enhance 5G system for smart manufacturing. This project is under the framework of Horizon 2020 Research and Innovation from European Union. And as you can see, we have a very good mix of ICT and OT partners all across the Europe. The project is coordinated by Ericsson, and ABB is the technical coordinator of the project. You can always receive more updates and news if you visit the 5gsmart.eu website. Now I will move on to the second point of the presentation on explaining you at very high level how 5G interwork with industrial applications. So when we talk about integrated wired and wireless infrastructure, a successful integration of 5G deployment in a smart manufacturing domain should also consider network management. And here, 5G system should always interwork with industrial application and existing network management system. And for that, the industrial application developers and also the existing network management solution should not require in-depth knowledge on how. Sorry, my slides are flickering. So the existing industrial application and the network management solution shall not require in-depth knowledge of the 5G system functionality and also to enable this network configuration. And this is the main motive. And this can be done with 5G industrial exposure capabilities, which enables the interworking of 5G system with industrial application and also with existing industrial network management solution. And this is done using standardized APIs. These are defined by 3GPP. So 3GPP since release 15, 3GPP, as we all know, is a global communication, mobile communication standardization body. And the way it works in 3GPP, we have releases. So release 15 was the first drop of the technology where we have 5G was introduced. And within this release 15, common API framework CAPIF was introduced along with network exposure function and network slicing framework. This framework provided a very unified approach on how these APIs can be exposed to several applications. And in release 16 and 17, SIL, Service Enablement Architecture Layer, along with NEF enhancement and network slicing enhancement were introduced. This allowed more vertical specific functionality exposure. For example, specific to V2X communication, specific to factors of future applications. And right now, 3GPP is finalizing in release 17 the enhanced functionality of SEAL towards smart manufacturing application. Also, what we see in industrial alliances such as 5G-SMART recently published a white paper on this 5G exposure functionality. And this document provides a very good overview on the functional requirements on how 5G capabilities should be exposed towards this industrial application, making it very simple to use and easy to integrate. And this use case considers wide range of aspects. If we want to categorize it, it is mainly device management use cases and also the network management use cases. So this is what is happening in 3GPP and in 5G-SMART. Now I will quickly provide you an overview of how 5G system interworks with existing Ethernet-based networks. So after the first release of 5G system in release 15, 3GPP started working on how 5G system should interwork with existing Ethernet-based industrial network. On the slide, you can see a typical Ethernet network where you have a couple of bridges and hosts which are communicating with each other over this IEEE specified Ethernet-based network. So in release 16 and in release 17, 5G system has introduced several capabilities. And today, 5G system supports Ethernet and is also compatible with IEEE standards relevant to industrial automation, such as IEEE TSN, time-sensitive networking. And this allows very seamless interworking with Ethernet deployments, such as LAN or TSN deployment in industrial factories. So from outside world, 5G system is modeled as a virtual logical bridge. So as you can see in the slide. And on the user plane side, you have these ports, which are NWTT and DSTT. These are called device TSN translator and the network TSN translator, which enables functionality of IEEE TSN standards. And also it enables this integration at the user plane level of the 5G system. And at the control plane, we have this TSN-AF, so time-sensitive networking application function, which interacts with the central controller, that is this network management system, or in the case of TSN, we have this centralized network configurator. And this information is also based on the IEEE defined 802.1 defined standards. And there are all other relevant functionalities that are defined by 3GPP to ensure that the 5G seamlessly interwork with this Ethernet-based industrial networks. So this is how today 5G supports interworking with this wired infrastructure. Now I will briefly give you an overview of how the SEAL enables this interworking with existing industrial application and also the network management functions. So a high-level architecture that you can see on the screen on the right-hand side, where you have the SEAL client and server, which interacts on the northbound side with this industrial network management and the smart manufacturing applications. And this SEAL client and server also interacts with this blue box, as you can see on the screen, which is basically our 5G system, which consists of, of the radio access network and also the core network. So the seal client is basically sitting next to the UE, so the user equipment, in simple terms, mobile. And on the backend side, seal server is connected via 3GPP defined interfaces towards the core network. And together, seal client and seal server exposes APIs, which are very relevant for industrial application. So these are mainly related to group management services, location management, network resource management, network slicing capability management, and further on. Right now in release 17, 3GPP is currently finalizing the enhancement of this seals functionality within the seal server and within the seal client that are very specific to Ethernet-based deployment in the factories. This includes TSN integration support, QoS monitoring, 5G LAN grouping, time synchronization, geographic location and positioning information. So these are the various aspects that are currently being enhanced by 3GPP. So using this framework, one can enable exposure towards industrial application, and without having detailed information about how the 5G system works, an industrial application developer can consume these services via APIs and also enables at the same time enabling this integration of 5G system with the current networks. So to summarize, this framework simplifies integration of 5G system. It provides standardized APIs defined by 3GPP. It enables integration with existing network management system, including TSN. And also this APIs covers major use cases, including device connectivity and also the network management use cases. And this makes basically very simple for 5G to integrate with the factory network. So this ends basically my part, where I have given you an overview of how 5G system interworks with industrial application. Now I will hand over to Jose, and Jose will explain you and give you insights on how this tool was developed, and then it will also provide you basically a live demo of this tool in a network. Jose, do you want to take over?
Can I use, yeah, let me see if I can request control.
I think I will stop this. Yeah, I think you can now.
I think it's better I share my slides.
Yeah, let's do that. I will stop presenting.
Yeah. Okay, so can you see my screen now?
Yes.
But not in full screen mode. It's only
coming. It's coming. It's coming. Okay. What about now?
We can see it well, yeah.
Yes.
Yeah. Okay, good. Thanks, Dhruvin, for the intro. So this part of the seminar is mainly focused on the network slicing. So I will first start with some basics of the network slicing. What does it mean? How it's been defined in the standardization in 3GPP. And then I will move into practical deployment. So I will use our laboratory, so where we have some commercial base station, and then also our own packet core, on top of which we have implemented the tool that facilitates the usage of network slicing. So just to give an idea, so what does a slicing means, and why do we need the slicing? So the first thing is that, okay, network slicing is ideally, as defined, for example, in next generation mobile networks, is an instance that either fully or partially and logically, can be logical or physically, it's isolating an instance of the whole network. So basically, that means that from the radio up to the transport and even the core network, they are created as a separate entity on top of the physical infrastructure. So in that sense, the idea, why do we need this, is basically the idea is that different customers will have a complete subset of the network for their own usage. That means that they will have their own segment of the radio, their own part of the radio. They will have their own part of the transport, and they might even have their own packet core. And the main idea is that then they can separate a bit the usage of the applications depending on what kind of requirements they need. So in this case, for example, the network slices are normally provided, or it's being proposed that the mobile operators can offer this for the for the customers. So basically, mobile operator then that have some enterprise customers, and those customers, they want to have their own network. They want to have a full control of the network. So in that sense, the operator can create those slices and then assign them to those customers. But now the question is that in private networks, I mean, like for example, in a factory, in a mine or whatever, why do we need this slicing? So I think that the main reason is that in private networks, they can benefit this, from the network slicing to separate the resources and then assign those to different group of devices. So that means that within a single factory, there will be different type of devices with their own requirements in terms of traffic or in terms of delay. So in a factory, there might even be a higher variety of devices than in a commercial network. I mean, in a commercial network, most of the devices, or high percentage of the devices, would be the end user or the consumer type of devices, mobiles and so on, tablets and this kind of data. That is basically, they are consuming data mostly in one direction. So basically consuming data mostly download, like getting data to consume locally on the device. But if we move these mobile networks into the private segment, into the private networks like factories or whatever, then the diversity of devices, it changes a lot. So basically in this kind of network, then we have sensors, we have actuators, robots, and so on. And each and every of those devices have a completely set of requirements in terms of performance and even security. So basically, some of these devices, I mean, if we are talking about sensors, the communications are very scattered and basically small transactions, mostly uplink. If we talk about robots, then the highest priority is the latency. So they want to have a high availability of data transmission. So that sense that the slicing, which originally was conceived to be used by the public operators for assigning those slices to the different enterprise customers, even in the private deployments, is requiring this kind of, it can benefit from this kind of functionality. So one concrete example in terms of security is that, for example, the IEC, the standardization on industrial and electronics, they define the concept of a security zone, which means that within an enterprise network, they have different areas that require different access. The sort of connection to this part of the network needs to be secure, and that means that the network slicing could be used in this case to be isolating this part of the network as a separate slice. So in this kind of example, if there is an enterprise or a factory with different plants, and then even within the same plant, they have different areas like operation and management or safety control area, those areas then might have a specific restriction in terms of which device can access and so on. So in order to fulfill those requirements of these kind of security zones, the slicing might fit and then can deliver this kind of isolation of the access. So if we look at now, I mean, after a bit of an overview when or why we need this slicing into the private environment or specifically in the industrial, then if we look at the architecture, so basically, and as Dhruvin indicated in release 15, there were added what is called in the 5G, the service-based architecture, which in practice, the idea is to separate a bit all the network functions. So in the 4G, there was a big set of network components managing the mobility and so on, and the session and the data. Now in 5G, there are a much larger amount of network functions. So basically, and the functionality has been reduced. So basically, there are more components with little functionality or less functionality as before. And then in that sense, for example, now the idea is that those components can be scattered across the network. So basically, they can be distributed, fully distributed, depending on we want to run the sort of signaling on the cloud while the data management on site on the factory, or even have multiple instances of some of these network components. And there is where, for example, the network slicing can utilize this kind of architecture. So we can see we have the access and mobility management, which is the one taking care of the access, user authentication, and so on. The session management, which is the one that takes care of setting up the sessions. And then one important component is the user plane function, the UPF, which in this case, it can be distributed in different parts. So if we look at the slice point of view, we could say that we could deploy one of these user plane functions in different parts of the network. And then each of those user plane functions could be used or allocated to each slice. So that means that the core component is separated for the slice. In that sense, all the traffic that will be sort of part of this slice will be managed by this network function. So in that sense, with this architecture, we can deploy easily, well, at least it can be deployed, the network slicing, and then it can ensure that all these different slices will have the proper reliability and access to the data network. Because at the end of the day, in those diagrams of the factory, each zone might have its own slice, and in that zone, then we could have one UPF that is taking care of the restriction to access that part of the network. If we look at the network specifications, one basic term that we need to get familiar is the NSSI, so the network slice selection assistant information. So basically, that means that the slice, each slice, is assigned one identifier, as we say. So basically, this identifier consists of two elements. One is the slice type or the service type, and then the second is the slice differentiator, SD. The main reason is that one single device can have up to 8 slices. So that means that each user, each device can request from the network up to 8 different slices, each of them with different requirements. So in 3GPP, they have been defined up to now 4 types. I mean, we are missing the latest, that is type 4, which is for vehicular type of communications. But the basic ones is that the type 1 which is the one that is used by default. So this one slide type 1 is the mobile broadband. So this is the normal data, the normal slice that is used for data, consumer data. So for streaming, for broadband applications, file transfer, and so on. But then in order to utilize or deploy the 5G into this kind of industrial environments or into these different verticals, 3GPP has defined a new set of types. So basically, one of the most relevant or most interesting for the industrial area is the URLC, ultra reliable low latency communication, which is type 2. So this type, what it means is that the traffic or the users that will be requesting this slice, they will have a high, low latency type of communications. The delay that should be delivered with this slice, it should be much lower than the normal mobile broadband and so on. And then another slice is the massive IoT. And in this case, the idea is to handle a smaller packet sizes, but a huge quantity of those. So basically, this slice will be requested normally by sensors or these kind of devices that there will be a large amount of those distributed into the network, and then they don't require low latency, but they require a huge amount of connections. So, and the fourth one is the vehicular type of communication. So in this case, it will allow the vehicle-to-vehicle type of connectivity. So when defining the slice, the slice, the primary element to identify one slice is the NSSI, this network slice selection information. So this is the first thing that we need to configure in the system when defining one slice. Then the next thing is that, as indicated, the slice comprises an end-to-end type of connection. So basically, that means that the slice will require resources on the radio. It will require resources on the transport to ensure that the traffic from this slice will be sort of isolated or will be separated from the other slices. And then, sorry, it also requires resources on the core network. So basically, if we look at practical usage of the slice in the core network, the easiest way is to have a separate user plane function that will be allocated for the slice. We could also have some other network functions or even the whole packet core completely deployed for the slice. But a simplified version of this core network function is that, okay, we have one UPF that will be selected to serve all the traffic from this slice. So in a nutshell, what we need when we are defining the slice, first we define these IDs, the NSSI, but then next we need to tell the network that, okay, I want certain amount of resources on the radio, transport, and core. How this is done, according to the 3GPP in 70 specification 28531, they have defined a separate component that needs to take care of allocating the resources for the slice on each of the subsystems, on the radio, transport, and core network. And this is what we have, like from the upper layer, the user will interact with the network slice management system, which then needs to talk to those subsystems, the radio, transport, and core, make sure that those systems will allocate the necessary resources. Then the next thing is, how do we define a slice? I mean, basically, okay, we know that a slice is a set of resources on all these subsystems, but then how do we tell the system what are our requirements? I mean, what are the features that we want to assign to this slice? So then here we comes the 3GPP that defines the new specifications 28541 that specifies the model, the resource model that decides what are the features or the characteristics of the slice. So, and this is on the bottom, all this data model that will identify, for example, what is the sort of NSSI that will be allocated to the slice. So the other thing is that the slice can be spanning several operators, physical operators. So that means that the slice can be built on top of different mobile operators with their own ID, P elements. Then the slice, we can define how many users are allowed to access this slice. What is the latency? What is the quality of service that we want to assign to this slice? So in this set of modules, in this set of metadata, the user should specify the slice. I mean, from the top, and then going top down, the network slice management will translate this information into the specific policies onto the specific configuration that needs to go to the RAN, to the transport, and to the core, and selecting all the resources that are needed for the slice. This is a bit the process. I mean, it's a bit just to give you an idea. So when the user has to request a slice from the network, the first thing or one option is that the user or the device already have that information from the previous registration. So in that sense, if we have a device, in this case it's a drone, and that device already got this information about the slices, then when that device connects to the network, it will tell the network that I want this slice because I'm gonna require this low latency. So I want a slice type 2 with URLC, and then I want to get assigned all the resources that I will need for sending my traffic. And then the network, the AMF, will check from the UDM, user data management, whether this user has been authorized or has allowed in the subscription this slice. And if that's correct, then the AMF will check with the network selection function, the NSSF, that is this user, can we assign this slice to this user? And if okay, then from that point on, the session for this user will be assigned this low latency. But then the problem that we are facing as of today is that most of the devices, they don't even know about the slices. I mean, the devices that we get from the market now, they still are not aware of what the slice means and how to request the slice. So in order to deliver those slices, then from the radio, from the network, we have to do all the heavy lifting. So that means that in this case, this is the second scenario that is defined in 3GPP, where the user does not have any NSSI from previous registration. So in this case, the idea of the difference is that we have defined, as you can see on the right-hand side, there should be some entity, like in our case is our network slice management system, the control center, the one that tells to the network, to the data management, to the repository, please assign to this device the following slice. So that means that when that device connects to the network, it doesn't have any SSI, so it's not requesting anything. But the network knows that, okay, this user has already a profile with this following slice. So then we will assign to that user the slice that has been pre-configured by the network slice management system, or that I will show later. And all the traffic coming from this device, then will be allocated all the resources, radio, transporting core, that we have assigned or reserved for this slice. So that means that all the sort of management, all the allocation happens from the network point of view. So then we can still deliver the network slicing, even though the devices are not capable of requesting those as of at least the commercial ones that we have been using.
Jose,
Yeah.
I think we should move on to demo, I guess.
Oh, okay, sorry. Yes, okay, so just, sorry, I'm getting too emotional here. So, so this is the setup I want to show. So basically, we have the base station, the baseband unit. This small box on top of that is where we run the core. I mean, the idea is the core is as simple as possible. And then on the left-hand side, the upper part is the radio head of the 5G, and the small device here is the end user device. Okay, so this is the starting point to configure the network slice. So first we need to configure the slice on the radio. So instead of boring you with this, I can show you. You can still see my screen, right?
Yes, you can.
Okay, so let's log into the base station. This is the console of the base station. It's a real base station that we have here in the back. I can show when I move around. And then we go to configure what would be the slices. So to give you an idea, let's see, we have a configuration here. So this is, first of all, one of the first things that we have to configure is the radio profile that we want to assign to the slice. So it's this network radio profile, the NRDB. And here then, as you can see, we can assign a DSCP. A DSCP is the value that the base station will mark all the traffic that is coming with this radio profile. And then here we can also assign what is the weight or the scheduling weight that the base station will assign to the traffic with this profile. So you can see this. This is another profile, schedule weight, and then here is another profile, so DSCP3, and then, for example, we have schedule weight 40. If you compare to the previous profile 2, the schedule weight was 1 and the DSCP 2. So this is the first thing. In the base station, we need to configure these profiles. And then we need to associate that profile, if you remember, network radio profile 2, to the 5QI. 5QI is the quality indicator for in 5G. And this 5QI, as you can see, is assigned to this NSSI1. The same, if we go into the 5QI2, this is the 5QI value 6, radio profile number 3, which has its higher scheduling priority, and then network slice 2. So this is defining the priorities on the radio level and associating those priorities to the 5QI parameters. So then, if we go down, we see that here are the NSSIs. That the NSSIs, we see the slice type here, slice type 1 for this NSSI1. And then slice the NSSI2 is also slice type 1, but SSD2. So that means that now I have created 2 slices, 1 and 2, same type, media broadband, but I have differentiated, I have separated them with the slice differentiator. And then for this tracking area, I have defined these 2 slices. So basically, that means that when a device connects to this base station in this tracking area, it has these 2 slices available. So now, and these 2 slices, they will be associated to a 5QI parameters that have been defined before. Now, if I jump into, let me see, This is our graphical interface that is showing, this is our base station. I mean, our office is here. And then I have already one device connected, this dark blue dot with the IMSI number ending in 1. And there are some other devices here that are registered, 33 and so on, but they are not active. So I keep them on idle mode. Then if we go into this, by the way, this is live. I mean, this is, I'm accessing the core, which is behind, and I can show you afterwards. If we go here, this is the operator. Here is the subscribers. So these are the list of devices that are in the system. So you see the number 1 that is registered and connected. And it has allocated a slice, the default slice, which is slice number 1 with the slice type 1. If I try to edit this device or change the slice, you see there's only slice defined. There's a default slice. So then we go, and then I'm gonna define a new slice. So this is the default slice, which if I edit, you see that I have a maximum of 100 UEs. I have assigned a different UPF with a data network named Internet, the default 5QI, that if you remember was defined in the base station with the best effort and the lower scheduling weights. And then this is the default one that each and every device that is added to the network over here will always get this slice. Now we're going to create a new slice. So let's say factory. I was checking this. And now I'm going to assign a different data network, which means it will have a different UPF. So I select this one. Let's say I want to assign 10 users, latency 20. Then if I want to go to 5, and then 1 gig data maximum for this slice. So that means that when I create this slice, there will be a maximum of 10 UEs that can access this slice. The idea is that the slice will allocate the resources to guarantee this latency. And then on the radio, we assign this 5QI. That 5QI is the one that previously I defined in the base station with the highest sort of scheduling priority. So now I create a slice. Now we see that this factory slice is created, but it's not active. What does it mean? That in order to the metadata that I described before, I mean, all the number of users, delays, and so on, and the 5QIs are created. But now the tricky point is that we need to allocate the necessary resources. So then we need to activate the slice, and then it will look what the system will look, I mean, interacting with this RAN, transport, and core subsystem needs to look and see what are the base stations available that support this kind of requirements. So now we see that, okay, this is the slice type 1, you remember, NSSI 1, and this is the slice 2, NSSI 2, where you see the slice type is the same, 1, but the slice differentiator is 2. So it's a different slice that we allocate to this slice. So now, if I go to this sort of subscribers, then I want to, let's change, okay, this is connected, let's keep it connected. Then this one, 33. Now we see there's a new slice, and I can assign this slice to this user. Now, when I assign or save this, that means that when this user connects, then it will get all the resources that are allocated to this slice. One thing that might be of interest is that we can even assign a static IP address to that device. So normally the core, they use a private range of IP addresses, but then we can also assign a sort of predefined IP address to this device. So now we see that this number 33 is assigned the factory. It's not connected, so now we go and connect it. So for that, I need to move my screen. Again, this is live, so bear with me. Okay. All right, so first I can show the base station. It's right here. I know it is visible.
Yes.
Yeah, okay, so this is the base station and this is the core. So basically, and you see the lights, I mean, it's blinking, so it's real. And then we're going to the room. On top of there is the base station, the radio head, and here is one of the devices. This is the one that it has the internet connection. And then we go here. So I did some, so basically this one has the internet UPF. So unfortunately in our office, we have a very bad connection to the public internet. So we only get about 4. And then even if with the speed test, coming, yeah, here we go. Yeah, then the same order. It doesn't matter whether it's a speed test or fast. So now we are going to power up this other device here. This is the second device. And this one is the one defined with the sort of factory. Let me see if I can plug it in. So it's difficult to. Okay. Oh, can you hold this? Yeah, thanks. Okay, no, thank you. All right, so now we are plugging this other device. And then basically, if we go to, see, now it's only this one. So in the meanwhile, this one is booting up. Can you see the device, right?
Yes.
Yeah, okay. So then as soon as this device is connected, then we should see in the screen a new dot. Not yet. Okay, now you see this second dot.
Yes.
Yeah, this is one, and this is the other one. All right. So then that means that this one should be connected now. Yeah, and this is, let's see if it's connecting. Okay. It is not connected yet. Yeah, now you see 500, 600. Okay, 430. So you can see our local network in the office is much better than the public internet. And then this one, let's see. Yeah, okay. Oh, what happened? Yeah. Let's give it a try. Okay, now with the speed test to see what it gives us. 380, 90. Yeah, it's around the same. It doesn't matter whether it's a speed test or this other application.
Jose, we have only 4 minutes now. We can also,
okay.
after
okay,
4 minutes, we can start Q&A. So you can still continue for 4 minutes.
No, I think that that's fine. I mean, basically, I wanted to also change one device from one slice to the other, but it takes a bit time because then I need to change the device and so on. But well, basically, that's what I wanted to show. I mean, let's see, what else do I have? Yeah. So now we see this the two devices that are connected, and then the other thing that we could show is to create 5G LAN groups, where the idea here is that we define a sort of virtual network with the devices inside the slice. So basically, the idea is that once we have created the slice, if we want that those devices that talk to each other, then we can create also like a virtual LAN group, and then okay, we select from which device the groups of this virtual LAN will be created. Then we can also define the type of connections for those devices, IPv4 or Ethernet. Unfortunately, the devices now they don't support Ethernet, so only IPv4, and then we can select devices within this slice that will be part of the group. So that means that when these devices they connect, they can talk to each other. So I think that's the other thing I wanted to list. Then one thing is that with this service-based architecture, the other feature is that we can deploy multiple instances. So, for example, this is the configuration of the gateway, the UPF, that then can be assigned to the different slice. This is basically a snapshot of what I showed in the demo, how to define the configure the slice, assign the slice, and then basically as a summary, the main point is I wanted to highlight that network slicing has a huge potential to support different verticals. So basically both in public and private networks. And then the 3CPP has done a good job in defining all the metadata that is necessary to hide all this complexity. So basically, as you saw, the main I would say complex part is to define the radio parameters or the radio priorities that you want to have on the slice. But then from that on, with our management system, we try to hide all this complexity, meaning that, okay, once the user define all this metadata, then the system automatically fetch that information from the base station, fetch the information from the metadata, and try to map into the specific resources. And in that sense, we hide all this complexity with some sort of user-friendly system. And I think that's all I wanted to say.
Yeah, thank you, Jose. So I think 5 minutes are left, and we can now move on to question and answers. If there are any questions, please feel free to add in the chat. Just to summarize from my side, what we saw today, we saw how 5G interworks with industrial application. What are the technical features that are coming from 5G side that enables this integration? And then also we saw the prototype of network slice and how it works. And this is what basically is part of a development from 5G-SMART. We have one question in the network slicing assignment process 2. How is the right slice chosen for the first time for an UE if there is no info in the UDM about the subscription information? Jose, maybe you can handle this.
And that's a good question. And the thing is that in the system we have to define the default slice. There will be always one slice. So that slice is what in, for example, 4G, it was the default bearer. So basically, when a user gets the subscription in the 4G, it always had this default bearer. In the 5G, it has the same, but instead of default bearer, it's called the default slice. And that slice, it has the same 5QI or the same quality parameters that were assigned as part of the default bearer in 4G. So there will be always one system or one slice that is available. And unless the operator or the manager of the network creates and assigns a new slice, all the user will always get that same slice. The parameters are the generic UPF, which is configured for access to the internet, and then the best effort 5QI, which is 5QI 9. So there will be always one. Welcome. More questions?
Okay, if we don't have any questions, then I think we can conclude the webinar. Okay, we got one more question. When you talked about network slice subnet, is it the TN, CN, and RN slice subnet, or can there be more specific subnets? Maybe Jose.
Yeah, no, I mean, according to the 28531, they have defined only 3 subnets. But then in terms of subnet, it's not a sub network, it's like a subsystem. So when I was explaining the RAN subnet or the transport subnet, it basically consists of the system that involves the radio, all the base stations, the system or the subnet that involves the access between the base station and the core network. So basically all the network functions that are running on the core. So that means that these subsystems are the 5G network. But then those systems, then they have to connect to different data networks. So basically, in one of the diagrams, I showed that a factory can have different plants, different rooms, and then that room could have its own data network. So basically, if there's a room which, according to the IEC, has some specific security restrictions or security zone, then that room can consist on a separate data network. And then to access that network, then we will install one UPF, and then we will create one slice that takes all the traffic across the radio, transport, and the core and terminates into that UPF. So then the traffic goes from there to that room only, so to that specific data network. And then there can be as many data networks as the factory or the operator decides to. So it can be one per room or one per floor. So it's up to the deployment.
Thanks, Jose. I think time is already up. I would like to now conclude the webinar. Thank you for joining. Thank you for listening us about the work what we do within 5G-SMART. And yeah, so I think with that, I would conclude the meeting. Thank you again. Bye-bye.
Thank you. Bye.
Bye. Thank you to you.